Hey, welcome back to Math with Patrick. Today is September 26th, and we're solving problem 269 from the Daily Epsilon calendar. And the answer today should be 26 because it matches today's date. And something I just realized, if you write today's date in like day, month, year format, then we can see problem 269 right here. So that's kind of fun. I don't know if other dates do that, but it's just something I noticed. Anyways, we're supposed to solve for x here, and we have some kind of, looks like quadratic equation, although we are setting it equal to some kind of square root on the other side, so maybe this isn't as easy as like a standard quadratic equation. And we have this condition that x is greater than 0, so maybe that means that there's like a second solution out there where x is negative. I'm not sure. And normally what I would do here is like, oh, look, there's a square root. We could like cancel it out by squaring both sides. But I do notice that the thing underneath the square root, that radicand, is actually a perfect square itself. This is just x plus 2 squared. And here, I could cancel that square and that square root. So we get like 2 times x plus 2 on the right side. Now we do have to be a little bit careful when we cancel squares and square roots, because here if I plug in say like a -5, we would get 2 times -5 plus 2, and that's going to be -6 because this right here is a -3. But if we tried plugging in that same -5 up here, we would get square root of -3 squared. And evaluating this just with order of operations, -3 times -3 is 9, and then the square root of 9 is only +3. So by canceling the square and the square root, I might lose some information about whether that quantity x plus 2 is positive or negative. But fortunately, since x is greater than 0, x is positive, and x plus 2 will always be a positive number. So I don't really have this issue of maybe accidentally not considering what might happen with square or with negative numbers. So these are completely identically equal to each other. There are no hangups here, specifically because x is greater than 0. On the left side, I could just rewrite that quadratic x squared plus 4x minus 724. And usually when I'm working with quadratics, I like to just set everything equal to 0, see if I can factor it. So I will expand the right side, and then I'll subtract the 2x, and I'll subtract the 4. So I get x squared plus 2x minus 728, all equal to 0. And so now I need to figure out what are two numbers that multiply to 728 and add to +2. Now I'm at a little bit of an advantage here because I actually recognize the number 729. I believe this is 3 to the power of 6. Now I might be wrong on the exponent. Let me just double check. That's 3 to the power of 1, which is 3. The next power would be 9, 27, 81, 243. Okay, cool. And then once we multiply this by 3, we should get 729. That's a 9, that is a 12, and then that's a 6 plus a 1, so a 7. Okay, so I did recognize that 728 is real close to 729, and I want to use like this kind of factoring strategy with a difference of squares to show that 728 is going to be the same thing as, well, that's just the same thing as 729 minus 1. And both of these are square numbers. I could do, I think, 3 cubed minus 1 and 3 cubed plus 1. And so if I distributed all of the things here, I would get that kind of difference of squares pattern where I get the square of the first thing, which is 3 to the 6th, minus the square of the second thing, which is just 1. And then to me, this shows that I can factor this new number, 728, as just 1 more than 3 cubed times 1 less than 3 cubed. And so I know that this is going to be 26, and this is going to be 28. And this 728 is negative, so that suggests that one of these two numbers, 26 or 28, is negative. And then this plus 2 in the middle suggests to me that the 28 is the positive one, just because this kind of plus 28 outweighs the minus 26 if we were to distribute everything between these two binomials. Cool. So I found a nice factoring for our quadratic. The left factor, if this is a 0, the whole product is a 0. 0 times anything is 0. So if I slot in a 26 right here, this whole factor turns into a 0. And then likewise, if I slot in a negative 28 into this spot, this whole factor is 0. And then 0 times whatever that number is also going to be 0. So this problem gives us two solutions, though knowing that x is positive, we can ignore that one. And I guess we're all done. So that is the solution. I guess you would just kind of do a little bit of perfect square simplifying on the right side, set your quadratic equal to 0, find a nice factor pair, this times this, and then we can see that x is 26 for today. So I think I'm all done. Thanks for watching, and I'll see you tomorrow.